we need to be able to find the least common denominator. Some people get good enough at this that they can often just say what the least common denominator is. But let's assume for a second like we're not quite that good. So we have 2 times 3 times r. That is the factorization of the first denominator. The complete factorization of the second denominator is this. And now we want, just like in the last section, we want to create one thing that we can put a copy of here and a copy of here, and it can cancel all these parts. So the one thing has to have 3 2's times an r to cancel these. The question is that enough stuff? And the answer is, it's enough 2's, it's enough r's, but we're missing a 3. So there's got to be a 3 in it. And so the least common denominator is 2 times 2 times 2 times 3 times r. That's 4 times 6, which is 24r. So the least common denominator is 24r. So what we're going to do is we're going to rewrite these two fractions in our subtraction problem. And when we rewrite them, they'll have the same value. It's just that they'll have matching denominators. So what do we have to do to this denominator to make it be this denominator? What do we have to multiply it by? How much bigger does it get? 6 times 4 is 24. So we're multiplying the bottom by 4 to get 24r. So we multiply the top by 4. 1 times 4 is 4. If you're new to this, you can check to see if you've made some good moves and have done some good work by canceling this and seeing if you cancel this fraction. If you get back to where you started, 4 goes into 4 once, 4 goes into 24 6 times, and so this would reduce to 1 over 6r if we wanted to go backwards. Here, what do you multiply 8r by to get 24r? You multiply it by 3. So you have to multiply the top by 3 as well. Now this problem will have the same answer as the original problem, but this problem we can do because we have common denominators. So now we just do the work in the numerator. 4 take away 9 is -5, and we have -5 over 24r. Nothing cancels, and we're done. Here we're also going to find common denominators and use them, but before we try to find a common denominator, it would be a good idea to factor the given denominators. So now our two denominators are this and 3, and so we need something that can cancel each of these. The something has to have an a plus 3 times an a minus 3 in order to cancel these guys, but it's also got to have a separate little factor of 3 to cancel this guy. So this is the least common denominator, so we're going to use it. Some of these problems can get to be quite a bit of writing. So now what do you multiply this original denominator by to bulk it up into this one? And the answer is it needs a times 3. So we're going to multiply the top by 3. 3 times 3a is 9a. Again, if you were to reduce this fraction, 9a on top and this on the bottom, you would get back to the 3a on top. So it goes backwards. Now this next one is a little bit terrible. What do you multiply 3 by to bulk it up into this? Well, the answer is a plus 3 times a minus 3. So we've got to multiply the top, a, by a plus 3 times a minus 3. And that's a fair amount of work. So now we're going to use the common denominator. And we're going to collect some like terms. So we have a 9a plus, and this will be a times, and a plus 3 times a minus 3 is a squared minus 9. And so we're going to have on top 9a plus a cubed minus 9a all over 3 times a plus 3 times a minus 3. And the 9a and the minus 9a cancel, and we have a cubed over 3 times a plus 3 times a minus 3. There is not a factor of 3 on top. It's just a times a times a. There's not a factor of a plus 3. There's not a factor of a minus 3. Nothing cancels, and we're done. Again, in order to get common denominators efficiently, it's a good idea to factor the original denominators first if you can. So I factored the x squared plus 9x plus 20, and then I'm going to factor the x squared plus 3x plus 2. Now, I don't know if this is too soon or not to do this, but we're going to try it. Let's try building the factors that we need. On the second denominator, I was looking at problem 46 inadvertently, and I copied down the wrong denominator, so I copied down the correct one and factored it. And so now we're going to try to look at what we need. Our least common denominator has to cancel this, so it needs an x plus 3. It has to cancel this, so it needs an x plus 4. It has to be capable of canceling this, so it needs an x plus 5. And those 3 binomials are enough to cancel these 2 and to separately cancel these 2. So instead of writing all that work over here, I'm just going to put it down. This is why I taught you this method for least common denominators. Many students can get to the point where they can kind of find it in their head, and they start to feel pretty good about that. So now the question is, can we change these 2 fractions into fractions with common denominators? Here, what seems to be missing is an x plus 3, so we're going to have to multiply the bottom by x plus 3. So we're going to have to multiply the top by x plus 3. Here, what seems to be missing is the x plus... Something is wrong with my work. We have an x plus 3, an x plus 4, and an x plus 5, and my 5 does not look like a 5 to me, so apologize for that messiness. So what we're missing is an x plus 5. You must multiply this denominator by x plus 5 to get to this one. And so we have these 2 numerators. Distributing here, we get x squared plus 3x. And distributing here, we get minus 4x minus 20. And that equals x squared minus x minus 20 over all 3 of these little binomials. But x minus 20 factors into x minus 5 times x plus 4 all over those same 3 binomials. And the x plus 4's cancel, and we get x minus 5 over x plus 3 times x plus 5. These 2, x minus 5 and x plus 5, are not opposites, so they do not cancel to -1. So we're done. When you turn a subtraction around, you get the opposite. So if I multiply this numerator by -1, I can do that by simply turning the subtraction around. Notice over here that 4 minus p plus p minus 4 does equal 0. So these 2 are opposites of each other. And when you multiply something like this by -1, you get the opposite. So I've, in essence, when I rewrite 4 minus p as p minus 4, I've taken its opposite. I've multiplied it by -1. And if I do that to the top, I need to do that to the bottom. So I've taken the opposite of the original numerator and the opposite of the original denominator, and that leaves me with a fraction that equals the original. And I really like that on this problem because it's going to make it much easier to finish. There are many other ways to do this problem, and the software teaches you a number of them, but I like this way. It's why I'm showing it to you. So the common denominator has to be able to cancel those two things. So the common denominator is the product of those two things. How do I know? Because if I take another copy of those two and put it up over here, then it has enough to cancel the p minus 5. If that doesn't make sense to you, you probably need to go back to some of the previous problems and listen to those instructions again. Here, we multiply the bottom by 1. We're not changing it, so we multiply the numerator by 1, and the whole fraction doesn't change. Here, we're going to multiply the bottom by p plus 5, so we have to multiply the top by p plus 5. Now we have the common denominator, p plus 5 times p minus 5, and on top we have p minus 4 plus, and then we have to multiply this out. It'll be p squared plus 1p plus 5p, that's 6p plus 5. So coming over here and bringing it up, we're going to have a p plus a 6p, so that's 7p. We're going to have a p squared still. So we have a p squared plus 7p plus 1. And then on the bottom we have p plus 5 times p minus 5. We need to see if this reduces, but p squared plus 7p plus 1 is prime, because you need two numbers that multiply together to give 1 and add together to give 7, and that's really hard to do with numbers that we know about. So this thing's prime, and it doesn't factor, and therefore there's no canceling, and so this is the final answer.